And hast thou slain the Jabberwock? Come to my arms, my beamish boy. O Frabjah's day, Callooh Callay, he chortled in his joy. 'Twas brillig, and the slithy toes did gyre and gimble in the wave. All mimsy were the bargoes, and the mum wraiths outgrave.
Was that even English?
That was the result of the allegedly mercury-addled brain of Lewis C. Carroll, the author of the Alice in Wonderland series. One of his most famous characters, the Mad Hatter, was totally nuts.
Within good reason.
Well, that's right, Britt. Hat makers of the 19th century often went mad due to having mercury additives in the glue. Constant exposure led to constant confusion, emotional outbursts, and weakness of the muscles. Eventually, it would lead to redness of the extremities, hair and tooth loss, kidney failure, and death.
That's right, folks. Today we're talking about mercury poisoning. A very real and recent problem thanks to the recent actions or inactions of a certain coal-burning energy company.
Now, when we say mercury, we're not talking about that silver stuff that's in old-timey thermometers. We're actually talking about a harmful compound called methyl mercury. Once methyl mercury is introduced to water systems, bacteria breaks it down and becomes harmful to humans and the organisms within those systems.
Coal ash ponds and hydroelectric power plants exist all over the country, and unfortunately, when companies cut corners or don't sequester their coal ash like they're supposed to, Duke Energy, all sorts of nasty stuff like hydrogen sulfide, lead, mercury, and well, all this stuff gets introduced into aquatic systems. Recently in North Carolina, this happened in the Dan and Yadkin rivers. As it turns out, inorganic metal mercury isn't really that harmful in itself in small amounts, but when it gets converted by bacteria to methyl mercury, it becomes a huge problem.
The change from mercury to methyl mercury allows the toxin to be taken up by fatty tissues within carnivorous organisms. Mercury both bioaccumulates and biomagnifies, which means it lasts for a very long time and is passed from one organism to the next when it's eaten. Something at the base of food chain, something like plankton, for example, is eaten by another invertebrate, which is eaten by a small fish, which could be eaten by a larger fish, which eventually is eaten by a human. Once it reaches the human is going to have 10,000 times more mercury in it than originated in the system. Methyl mercury is found to have a half-life of 72 days in aquatic organisms, and in humans, only 50 days, which means you're waiting about 2 months for just half of the toxin to leave your body.
The real harm comes from what happens once the methyl mercury gets into your system. A study of small mammals showed that organisms fed an intoxicating dose of methyl mercury started to experience lethargy, anorexia, motor and sensory defects, and eventually in extreme cases, muscle ataxia, seizures, and death. The onset time for small mammals is a lot shorter than for other animals, so they're particularly at risk. For example, the first case of mercury poisoning occurred in Minamata, Japan in the 1950s and 60s. Cats were seen dancing in the streets, and they would eventually lay down, have seizures, and die.
It wasn't until several weeks later that humans began to show the same symptoms. As they ate fish and used the water in the Minamata Bay, they began to develop full-on Mad Hatter's disease. Over 2,000 individuals showed these symptoms, and eventually 1,700 ended up dying as of 2001. It became a really big issue, and it actually became called the Minamata disease. There have been some recent outbreaks, well, not recent, but within the last 50 years, in Ontario, Canada in 1970, and also sometimes in Japan.
So, how exactly does mercury cause all this damage?
The methyl mercury gets into the bloodstream, and it can either go straight to the fetus of a pregnant woman, or it can whisk around the body, wreaking havoc on the kidneys, liver, and most importantly, the brain.
Survey says we need all of those things to be alive.
You're right, Britt, we do. Indeed we do.
That's right. So how does methylmercury get into the brain? It turns out that we have an amino acid called cysteine that likes to combine with methylmercury to form a methylmercury L-cysteine complex. This complex gets taken up by the amino acid transport molecule methionine. Methionine takes it straight to the glial cells, which are what make up the myelin sheath, a protective covering over the axon of a neuron. Neurons are what send signals throughout the brain and eventually the rest of the body.
These electrical signals are conducted by the passing of the sodium and potassium across the cell membrane. Here, we show how a proton pump works within a glial cell. The sodium is pumped into a cell, it depolarizes. And as the potassium is pumped out of the cell, it repolarizes. The depolarizing action sends a signal, and repolarization happens to restart the mechanism.
But when methylmercury enters the system, it likes to block off the pump. Now, unfortunately, we didn't have the funds to get Drake to do the rest of the video, so we'll be relying on this station's interns. Interns! Today's interns are sponsored by the letter L.
Hi, Mom.
It's the
Interns
only thing
don't
they're
speak.
sponsored by, because they're not getting paid for this. Anyway, as you can see, as long as the intern, I mean amino acid complex shaped like the letter L, is attached to the pump, it can no longer change shape to pass the potassium and sodium past their gradients.
And that, folks, is why you have to be careful about where your fish comes from.
Good evening, Kataba.
You have a great evening.